Okay, so this is chapter 2, beginning the problem-solving process. And let's see, I want to present. There we go. Okay. So the objectives for this chapter is to explain the problem-solving process. So when you're given a problem, which you're going to be given a problem for every single lab assignment, how do you go about solving it? And this might be the hardest part for some students. So this is a pretty important part, and a lot of people want to skip it. But if you're not good at solving problems, then here's your chance to learn step by step how to do that. So we're also going to talk about analyzing the problem, completing something called an IPO chart, which IPO stands for input, processing, and output. These are the things that you always need in a program. Somebody has to input something, whether they're using a mouse or a keyboard or a joystick. Many ways to input information: their finger, by touch screen, processing, and that's basically, taking the input and doing something with it, processing it. And then what's the output going to be? Is it something you're going to hear, you're going to see, you're going to feel? So that's the output part. We're going to plan an algorithm using pseudocode and flowchart. And remember, the algorithm are the step-by-step instructions that you need for the program to run. And first, we do that with something called pseudocode, which is just English-like words. And sometimes we create flowcharts, especially if they're really, really large programs. Flowcharts come in handy. And then we desk check our algorithm. So the desk check is something that is used by the person who's going to test the program, whether it's you or somebody else. So we're going to go over all those. So the problem-solving process, it says people solve hundreds of simple problems every day without thinking about how they do it. Understanding the thought process involved can help in solving more complex problems. You can also use a similar process to design a computer solution to a problem or a computer program. The first step in solving a problem is to analyze it. For example, paying and mailing a bill. So, analyzing meaning, what is it that I need to do, and start thinking about it. Next, you plan, review, implement, and evaluate the solution. And after this, it may be necessary to modify the solution. So, here's an everyday problem. It says, summary of the analysis and planning steps for the bill paying problem. So we got to pay a bill. So how do we analyze this and come up with a solution? Well, first we have to think is, what are the inputs? What items do I need to accomplish my goal? Remember, my goal is to pay a bill. Well, I'm going to need the bill that I want to pay. I'm going to need a pre-addressed envelope. I'm going to need a check, a pen, a return address label, and a postage stamp. Okay, so this is the old way of paying the bills. I pay my bills online using my bank, but if you wanted to, some bills I might still need to send in an envelope and put a stamp on it. So this would be all the things that you need to do that. So these are your inputs. You've got all these items. So what's the first step? Well, the first step is you would use the pen to fill in the blank check, the date, the payee, the numerical amount, and then you write the amount. Step 2, use the pen to sign the check. Step 3, use the pen to write the customer account number on the check. Step 4, put the return address label on the pre-addressed envelope. Step 5, put the postage stamp on the envelope. And so on and so on. So you get the point. Now, of course, we could put the stamp before we write the address, but we definitely cannot seal the envelope before putting the bill and the check inside. So this step 7 has to happen at this point after you do this part. But you could do this a little bit different. So you could start by doing your envelope first and then doing this part. But this step has to definitely be here, and of course you can't mail it until you do all these steps. So everybody's algorithm could be just a little bit different, and that's something really important because you're going to be writing programs. I'm going to be reading your programs and looking at them, and I want to see your original solution. I don't want to see you copying somebody else's solution. So everybody's algorithm, everybody's solution is going to look a little bit different because not everybody's going to think the same way. Not everybody's going to think that you should do the check before you fill out the envelope. Somebody may put the postage stamp on it before they fill out the return address. So it's just something to keep in mind, is that everybody's solution is different. Here's our goal or our output, which is paying the bill. So once everything gets done, this happens. The bill gets paid. Here they made a little modification to the original solution. So they put an if statement. It said if the bill has a return stub, tear off the return stub, blah, blah, blah. If not, make a copy of the bill for your records, so on and so forth. So they added an if-else statement in this algorithm. So creating computer solutions to problems is a very similar process to solving everyday problems. A computer program is a solution implemented on a computer. There are 6 steps to creating a computer solution to a problem. Step 1, we analyze the problem. Step 2, we plan the algorithm. Step 3, desk check the algorithm. Step 4, we code it. Step 5, we desk check the program with what we did here on number 3. And then we evaluate to make sure that we're getting the right output. And if we're not getting the right output, then we're going to modify the program. So we're going to go over all these steps right now. So analyzing the problem, it is essential to understand a problem before creating a solution. So if somebody asks you to write a program that calculates the area of a circle, and you have to, and you're going to get as input the radius, and you don't know what the heck area is, and you don't know what is a radius, and you don't know what the formula is, then you're not going to be able to solve the problem. So step 1 is you've got to understand it. You have to think about it. You have to figure out what is my goal, which is the output. What do I need as the input? And then always search first for the output, it says on here. So first is, what is my output? So in my circle example, my output's going to be the area. And then how do I achieve that? Well, they have to give me the radius, and then I have to create a formula to create the output. So here's an example of a problem. This problem is specification for Addison O'Reilly. wants a program that calculates and displays the cost of a TV which is finally on sale at one of the stores. The program should calculate the cost by multiplying the sale price by the sales tax and then adding the result to the sale price. So our input is going to be how much does a TV cost and what is the sales tax. Our processing, we'll go over this in a minute separately. The output is going to be the cost. So again, we always want to start with the output. So the output is going back to the problem. If you read it here, it says the program should calculate the cost. So that's going to be your output. That's what we do here. It's going to calculate the cost by multiplying the sale price by the sales tax. So you got to know the price, you have to know the tax. So this here is the we multiply a sale price by the sales tax to actually get the amount of tax that we're going to pay, and then we add that amount to the sale price. So here's our input. How much does it cost and the tax. And here they give you an example of what they do to analyze the problem. So they take away or mark out all the information that is not essential to figuring out the solution to the problem. So they want us to calculate and display. So that's essential because you're doing calculations and you're displaying. Again, like I said earlier, here they tell us what we're calculating and the inputs that we need. Some problem specifications contain incomplete information. Sometimes you might get a problem with incomplete information and then you're not going to be able to solve that problem. So let's look at this example. This one says that Cynthia earns $11.50 per hour. Last week she worked 45 hours. Create a program that calculates and displays her weekly gross pay. So okay, so she gets $11.50 per hour. She worked 45 hours last week. And so we have to calculate her gross pay, which would mean that we would have to know how much to take out for taxes and whatever else, whatever other deductions needs to be taken out for her gross pay. So here we could easily calculate the net pay, but we don't have enough information to calculate the gross pay because it requires deductions. This one says distinguish between information that is missing and information that's implied. So it says Gordon wants a program that calculates and displays the area of any rectangle. So for this program, they've given you everything that you needed, because to calculate the area of a rectangle, there's already a formula for that. It says any rectangle, so the input would be the length and the width of your rectangle. So you would ask the user to enter the length and the width, and then you would calculate the rectangle. So it would be 2 times the length plus 2 times the width would be the area. Or no, I'm sorry, that would be the perimeter. The area would be length times width. Okay, so this is just showing you that you might have a really simple problem. You might think that you need information, but you don't. because you have everything that you need here. Okay, so step 2, planning the algorithm. So they gave you a problem, you've analyzed it, you know what you need. Okay, so we're at this step here. What algorithm do I need to get the cost given the price and the tax rate of the TV? Okay, so the algorithm, like I said earlier, is just a set of instructions, step-by-step instructions to solve a problem. We're going to record in the processing column of the IPO chart the algorithm. And then step 3, we're going to do our desk checking. We're going to desk check the algorithm or verify that it's correct. So if we go back to, let's go back to this here. And I would say, okay, so what would be the first step in, so your lab assignment, they're going to give you a problem and you're going to create an IPO chart just like this one. And you're going to have cost and you're going to have sell price. Well, you're not going to have cost, but you'll have some kind of output. It could be one or more things that you're going to output. You're going to have input. And so let me see if I can see here. Okay, it's not what I want. And show. And let me get the slide so I can type in the algorithm. All right. I don't think it's going to let me type. I think that's a picture. Okay, well, let's take a look at this algorithm here. All right, so in this algorithm, what they're showing is they're asking the user to enter the sell price and the sales tax. And then in the algorithm, it specifically has to say how to calculate the cost. So they calculate the sales tax by multiplying the sales price by the sales tax. So here they're calculating the sales tax. So let's say this TV costs $100 and your sales tax is 5%. Then you would multiply 0.05 times 100. And so that would be how much sales tax you're gonna pay. So you're gonna pay $5 for that $100 TV. Okay, so that $5 they're gonna save it into this variable called sales tax. And I'll explain in just a second why they put it here. Then in the third step, we're going to calculate the cost. So what do I have to pay? Well, I have to pay my sales tax, which is the $5, plus the sales price, which was $100. So my cost will be $105. And then I have to display the cost, which is $105. Now, the reason that we have this processing item called sales tax is that anytime in your algorithm, if you have a variable that you calculate but you don't display as output, then you put it in processing. So let me say that again. If you ever calculate something and you don't display it, then you put it under processing. Now, if I would have displayed sales tax, if I would have put here sales tax and cost, then this would just be blank. I wouldn't have a processing item. So you don't always have to have a processing item. Another thing too is that some people, remember how I said people have different ways of creating algorithms, right? Because we all have different ways of problem solving. Some people may take step 2 and 3 and put it together. And they may say, calculate the cost by multiplying the sales price by the sales tax rate and adding the sale price. So if you put step 2 and 3 all together and you calculate the cost, then the sales tax goes away. You don't need this variable. It's an unnecessary variable. So processing items are items that you calculate but you don't display as output. And that will be important when you create your program for your lab assignment. Okay, so let's go back to where we left off. We're going to look at one last problem. And then we're done. We're done. Uh-oh. That's not where I want to go. Well, we'll just fast forward. Boom, boom, boom. Okay, so the gas mileage problem says Sheila Jones began her trip from Vermont to Oregon. She filled her car's tank with gas and reset its trip meter to 0. Okay, so she filled the gas tank and then she reset her meter to 0. So after she traveled 324 miles, she had to stop and refuel. The gas tank required 17 gallons to fill up. Sheila wants a program that calculates and displays her car's gas mileage at any time during the trip. The gas mileage is the number of miles her car can be driven per gallon of gas. Okay. So, the first thing that we're going to look for, when you read this problem, the first thing you want to look for is what is the output? What is it that they want? So, she wants a program that calculates and displays her car's gas mileage. The car gas mileage at any time during the trip. The gas mileage is the number of miles her car can be driven per gallon of gas. So number of miles her car can be driven. Number of miles her car can be driven per gallon of gas. So for 1 gallon, how many miles can she go? For 17 gallons, 17 gallons, she could drive 324 miles. So for 1 gallon, how many miles can she drive? For 2 gallons, how many miles can she drive? So let's see how they did it. So here we have miles per gallon. So anytime in the trip, if she types in the miles driven and the gallons used, it's gonna tell her how many miles she's getting per gallon. So the first step is to enter the miles driven and the gallons used. The second step is calculating the miles per gallon by dividing the miles driven by the gallons used. And the third step is displaying the miles per gallon. So the calculation was miles per gallon. Here's miles per gallon. So there's no processing item. It's just empty. There's nothing that needs to be added in there. The last thing that we have to do is we have to create a desk check table. So the desk check table is something that you use to test your program. So in the desk check table, you're going to have one column for each input and one column for the output. So here you have one input, two inputs, one output. Your desk check has one input, one input, two inputs, and the output. So the words, miles driven, gallons used, miles per gallon. Then you just make up some numbers, any numbers. Here, this number here, they actually got it from the problem. So the problem said that she drove 324 miles and her gas required 17 gallons when she refueled after she traveled 324 miles. So what you have to do is, using your calculator, you're going to type in 324 and divide it by 17, and it's going to give you 19.0588. So that rounds up to 19.06. So she's getting approximately 19 miles per gallon. And you want to then make up another number and see how many miles per gallon she's getting. So that is not correct. There's a problem there. I don't know why this says 1. It's supposed to be a different number. It's not supposed to be 1. So whatever number this is so many gallons used, probably like 18 or 19 to get this number here. And so we want to already know what the answer is before we create the program, because when you create the program, you want to have data to test it, and you want to know, the only way to know that this is correct is by actually putting it into the calculator. So don't assume just because you get an output it's correct. You have to actually make sure that you did all the calculations correctly. Okay, so this is our last step, is desk checking. Well, it's not the last step. You actually test your program. Then after you test it, let's say that you type in 324 and 17 and you get some weird number here, like, I don't know, 1.8, then you know you did something incorrectly. Your calculation was incorrect. So you would have to go back and correct this calculation here. Okay? So again, for your lab, you're going to create one of these IPO charts, and you're going to create one of these desk check algorithms. Okay, thank you.